Alright, welcome back everybody. My name is Dustin. And in the last video, we actually started working on creating an Asteroids clone. And we got this far. All we got is this little blue ship. Now, I ended up changing the way the ship is oriented, and we'll go over why. So I'm going to have to fix that, and I'll do that right now. So in my entity defs here, with my ship, I actually changed its orientation. So its width now is 80, and its height is 90. Okay, and we'll go over why later. First thing we're going to want to do right now is we want to actually start to create a ship class. So a ship class in Lua. Lua does not have the concept of a class because each object can actually define its own behavior. However, it is still possible for us to emulate classes and object-oriented programming in Lua. So we can just use something called the index meta method so that new objects will inherit their operations from the proposed class. Let's do a quick example of this, and we'll just call it the test class. So an example would be test class is equal to a table, because everything in Lua is a table. Then we want to say test class dot index. So our meta method is equal to test class. What this is doing is setting the index meta method to the test class table itself. Therefore, all fields that we set inside of the operations will be inherited by the created objects. After we have that set, we can now make a create function. So we go function test class. So it's in the namespace. So it's basically creating a namespace. That's what we're doing here. And we'll say create. And we're going to send in the params or parameters. And now this could be nil, it could be anything. It's up to you. You don't have to put params in here. Then we can say local this is equal to another table. So this table. So inside of here, let's just add a few member variables. So we'll just say m test1 is equal to params test1 or 10. And we'll do 2 or 15 for this one. No, actually, let's make it 7. 7 is lucky number 7. M test2. That's one cool thing about Lua is you can have this or. So if this doesn't exist, so if this index doesn't exist for this table that or definition that we're sending in, it will just put in the 10 instead. So we have our variables. You can add more variables as you need. Okay, so from here we want to set the meta table for the objects inside the class. So we go set meta table, this, I definitely spelled that wrong. Set meta table, this, and self. Self is referring to the test class table itself. So here we're setting the self table to this. And then finally we want to return this. So we're basically returning the contents of this out into the world. And then when we create a new, it's going to check our index for these values. All right, so now that we have a little test class here ready, so this is basically our test class. Let's just put this here. That's our test class here. Okay. We can now actually create objects of this. So we'll go local test1 is equal to test class. And we'll say create, and then we can send test1 is equal to 55. And we'll only put test1 in, so you'll see that test2 will automatically be 7. So in our update function, we'll just go print test1 dot m test1 and then m test1 and test2. When we run this, it should print that out for us. See, we set it to 55 and test2 is 7. Cool, so that's basically a class for us, and we can actually add different operations or different functions to the class, making it more in depth. What we're going to do now that we have a simple idea of what a class is in Lua, we can get rid of all of this and start our ship class. We'll start a new script, add over here, new. And we'll say ship.lua. And we'll go ship is equal to. So we're basically creating the namespace for the class. Ship.index is equal to ship. Then we go function, ship, create. And we'll take a ship definition. We're going to have local this is equal to a table. And we'll just put the set meta table in right now. Meta table. This. So, and then return this. All right. We're going to want to have the actual underlying entity's ID. We want to hold on to that. So m entity ID is equal to def.id. And in asteroids, the ship's going to need to move forward. So we're going to need like a forward thrust. So I'll say forward speed. So f forward speed is equal to def.forward speed. So if we actually want to set a forward speed, or we'll just set it to 10. And then the ship's also going to need to rotate. So we're going to need an angular speed. So we'll go m angular speed is equal to def.ang speed or 4. Awesome. So that's good to start. We'll start with that. So we basically have the start of our ship, but we're not doing anything with it yet. So what we want to do now is update the ship. But before we can do that, I'm actually going to want to go into our entity class here, and we're going to want to add in a new constructor. So if we go to our constructors, we have more than one constructor here. We have this constructor that takes in an entity itself. We want that in the field. So we're going to need to create that here as another one of our constructors. And we're going to want to put that in now. So it's going to be another lambda function. It's going to capture a reference, and it's going to take in an std into 32 t, and that's going to be our ID. And then we're going to want to return an entity that takes in the registry, and we're going to static cast to an entt entity, the ID. Cool. Sorry, this goes out here. Cool. All right, so now that we have that, let's go back into our ship.lua, and we're going to create our update function. So we'll go function, ship, and we'll say update ship. Now we should send in dt here, or delta time, but we'll worry about that a little bit later. Okay. So now we have the entity ID in the ship itself. We carry that around. So we're going to want to get the underlying entity itself from its ID. So let's go local ship is equal to entity and send in self.m entity ID. Okay. So you see this meta table, self is, we set this meta table to this. So we want self.m entity ID. All right, so now that we actually have the ship entity, we're going to want to get the components from it. First thing we're going to need is the transform. So local transform is equal to ship get transform, or get component, silly, get component transform, and then local sprite is equal to ship get component sprite. The ship will need to be able to move forward and backwards based on the current rotation of the ship. And since we're only using 2D, the angle of the ship will be consistent with the angle of a unit circle, where the equation of a unit circle is based on its angle, and that would be x is equal to cos theta, y is equal to sine theta, and the angle will be in radians. We can use this then to calculate the forward vector of the ship. And we'll do this like this. We go local forward is equal to vec2, and then we'll say math.cos, math.radians, transform.rotation. And that is our x value. Then we'll say math.sine, math.radians, transform.rotation. And that's our y value. Now this is just the direction that we're pointing at, that our forward is pointing at. If the angle here is 0, then the ship would have a 1 for the x and a 0 for the y. And if we multiplied that by the ship's speed the ship would be moving straight down the x-axis. So we want to be able to control the speed and the rotation of the ship using the keyboard. I'm going to use the A and D keys for the rotation of the ship and the W key for the forwards thrust. From what I remember in the original game, the ship cannot move backwards. However, if you want the ship to be able to move backwards, just use the negation of the forward vector that we just calculated. Okay, so now that we have this, go if keyboard dot pressed key A. Then, since we already grabbed the ship's transform value earlier, we can adjust the ship's rotation. So we go transform dot rotation is equal to transform dot rotation minus self dot m angular speed, because the A key is going to do our counterclockwise rotation. And then we'll want to copy all this and do our clockwise rotation. And this will be plus the angle. And we'll change this to else, so they're not combating over each other. Now again, we should be adding the delta time in here, but that's okay. All right. Before we keep going, let's go create a ship. So let's go back to main. And in here, we're already creating our entity. So let's create a global ship. We'll just say G ship is equal to ship create. And we'll have a def, and the def is just a table. So we're sending in a table, and we have the ID is equal to entity. Why is it equal to entity? Because this entity is just an ID. The load entity is returning an ID. And I don't care about the speed and stuff right now. We'll leave that. We can get rid of this test stuff here, and we'll go G ship update ship. However, this won't work because we haven't added into our run scripts yet. So let's add that in. Cool. Ship.lua, oh, capital S. So first off, I'm going to change that to match everything. Cool, ship.lua. And let's run it and see if we can get that ship rotating. Now we did add in that entity constructor, so it may cause an issue, but we'll see now. And it's rotating. Oh, only rotated the one direction. So that's going in our left. I want to go right. So let's go back and see why. Ah, yes. I didn't change the key. So I said A and D. You guys probably already caught that. So let's run it one more time real fast. And clockwise, counterclockwise. Cool, we got our rotation going. Perfect. Okay, so that looks good. So now let's add in the forward thrust. We're basically just going to be doing the same thing. So if keyboard dot pressed is equal to key W, now we're going to want to set our transform. And this is where our forward vector comes in. So we're going to want to say transform dot position is equal to transform dot position. And remember, the position is a vec2, so we can actually just add them, because the forward's a vec2, and we made those overloads inside of the bindings for the vec2. So we can just add these together, plus forward times self dot m forward speed. We also did a binding for these as well. So we can do our multiply. It'll multiply first, and then it'll add these together. Okay? And let's test that. Awesome. There we go. Whee! It's going. All right, good. Cool. So it's missing something, though. It's missing a drift. Like, the ship should be drifting when you stop pushing the thrust. At least that's similar. Our game's not going to be just like Asteroids, but it's going to be similar. So right now we need to add in our drift. I'm going to leave that for you for a challenge really fast. Take a second and think, what are we going to need for a drift? We're going to need to know how fast we want it to drift, and we're going to need to know the angle that we want it to drift, okay? So we want to be able to hold on to the angle of the previous forward, and that will be our drift. Okay, so take a second and try that now. All right, cool. So hopefully you gave that a shot. If not, we're going to do it right now. So let's hold on to our drift speed. Drift speed. And that's going to be just equal to 1. Actually, let's do, just in case you want to put it in as a def dot drift speed, just in case you want to change it later, but it'll default to 1. Okay, so drift speed, and then we're also going to need to hold on to the angle. So we go m drift angle, and we'll just say that's a vec2, and the vec2 is going to start just at math.cos of 0 for the x, and math.sine of 0 for the y. Okay, so now that we have our drift angle, if we're not pushing the keyboard, not the rotation, we want to be able to rotate it while it's still drifting. But if we're not thrusting forward, we're going to be drifting. And so we can basically just copy this. And it's going to be equal to the self.m drift angle times self.m drift speed. Okay? Now, I said before we want to hold on to the forward vector inside of the drift. So we would put that here. So we want to go self.m drift angle is equal to forward. So every time we thrust, we're changing our drift angle to the new forward. Okay, let's see how it is. So right now we'll actually be just drifting to the right down our x-axis because we're starting it at basically 1 and 0. So no, it's not going to be going up, it's going to be going to our right. And we're drifting. Cool. So if I forward thrust, see it's changing the drift angle. Cool. All right. So we got a problem. We go off the screen. Well, that's kind of a pain. So what we want to do now is when he goes off the screen on that angle, I want him to show up on the other side of the screen. So that's what we're going to do now. And we're going to want to be able to do this with multiple objects. So we're not going to just set it up in the ship itself. So we're going to put it up as a helper function. So we'll do that in utilities. So down here, we'll make a function called check pos. Now the check pos, I want to take the current position of the object. I want to take the width, and I want to take the height of the object that's going in. Okay. So we could have different sizes of asteroids, different sizes of ships, and we want to check their position. So then we'll go local min x is equal to 0. Local min y is equal to 0. Then we can say local max x is equal to, let's actually make a couple constants right here. So we'll say window width, and that's equal to 640 right now. And then we'll say window height is equal to 320 or 480, sorry. Okay, and then max x will be our window width, and local max y is going to be our window height. I don't want the ship to start on the other side until it gets past the window. So you want it to just touch the ends and disappear. So we want it to kind of go past the window width or the window min and max. So we'll check to see. So if position dot x, oh yeah, and the position going in is a vector. So position is equal to vec2 width slash height is just equal to a float value. Okay, so position dot x plus the width is less than min x. So if position dot x plus width is less than min x, then we're going to want to set the position is equal to position dot x plus window width plus width. Then we say else. Let's copy this line. So what this is going to do, it's going to put us on the outside of the window on the other side of screen. So and then we're going to want to check the opposite. So is our position.x greater than max x plus width plus the width of the object? And this needs to be an else if. Then we want to set it back to the position dot x is actually going to be equal to negative width. So what that's going to do is it's going to set the ship just outside the min end. Now we have to basically do the same thing for the y-axis. Now, there might be a better way to do this, but this way is working for me. So, if you can think of a better way, leave it in the comments below and we'll make the change. Height plus height. See, it's basically the same thing. Height, max y, height, y, and y. I don't think I missed anything. Okay, so now that we have this check pause, this is in the utilities function, we can actually grab that and let's do that right here. So we'll just go check pause. And since we already have the transform, we can send in the position transform dot position. And we also have the sprite dot width and sprite dot height. Awesome. Let's see if that works. Okay, so we're going to the other side. We should pop on the other side. There it is. Awesome. All right, so that one didn't work. Let's try it. Let me just run this again. Let's go up and see. Yeah, so our up doesn't work. And Y. You guys probably already saw what I did wrong. Position Y. Yeah, that's it right there. So you probably already saw that. And let's try again. Let's go up. Yay! Awesome. I don't know if that's the correct way to do it, but it's working for us. All right. So we got our ship moving, and that's good for this video. So I have a little challenge for you guys. I'm going to put out another video tomorrow, and in the next video we're going to actually create the Asteroids class. So I want you to basically do the same thing as the ship as a challenge. Create an asteroid class. So the asteroid, it's going to have a definition, and let's give it a type. So if we go into our asset defs, not our asset defs, sorry, into our entity defs, in our asteroids, we can add more. It just doesn't have to be components and groups. We can add more stuff in here. So let's give it a type, and the type is equal to small. And then we can have another one up here. Change this one to big or large. We'll say big. Yeah, that has to be a string. All right. So we're basically going to want the same thing in the asteroid. We're going to want the entity, and we're going to need to have a type and a rotation, because it's going to be rotating, but it's going to be rotating randomly. So you want to be able to figure that out. It's going to have a min speed and a max speed, and it's going to have a velocity. So we also want to do a random velocity as well. So try your best, see what you can come up with, and also have an update where it will update on its own. So it has to update based on its speed and its rotation and its direction. Also, it needs to have that check pause inside of the update. Okay, all right, give that a shot. That's it for this video. It's a short video, and let me know if there's any issues, and I'll see you in the next one. Take it easy.